Hi guys, so today we're looking at this BMW X5 E70. It's a 2007 model, and the problem with this one is the headlights. They are halogen headlights in this car, and they're pretty awful. The lenses are a bit fogged anyway, but I don't think that the halogen lights are very good on this car. So you can see at the moment we've got the side lights on, or the daytime running lights. They also come on with those, and they're also powered by a halogen bulb, so they've got this sort of yellow golden glow to them. But the issue with these is the main lights. So on these lights, the main beam is a halogen bulb, which is located there, and then the dipped headlights is also a halogen bulb, and it's located there. I'm going to replace these with some Xenon light clusters which I've got, but I just thought I'd show you these lights in the car before I start. So as said, this is the side lights, and there's a single bulb powering those rings. And then if we switch the dipped beam on, that's the dipped beam. I had to put the engine on, the battery was complaining. So that is the dipped beam, which, yeah, it's not totally dark at the moment, but you can see that it's not particularly bright, that light. And then main beam, and yeah, that's the main beam. So with the lenses being frosted the way they are, sort of in bad condition, it kind of glares the output of the lights. It doesn't give a true beam anymore. So yeah, they, like I said, they look bright on this camera now, but they're not. You know, if you look at the road there, you can see it's not really lighting up that bright at all. There was a few different lights that came with the X5 E70 model during its time, and these ranged from the first ones that came out, which was the halogen headlight. I'll put some part numbers up on the screen in case that is what you're looking for. But there was the halogen headlights, which had a halogen main beam and dip beam. Then there was the Bi-Xenon light, which is the one I've got here, and that had a Xenon D1S bulb for the dip beam and the main beam. And then the newer version, which is known as the LCI. So the other two, the halogen and the Bi-Xenon, they're known as pre-LCI, and then the newer type is it goes by the name of LCI. It has LED modules in it for the halo rings. Also has the same D1S bulb for the dipped and main beam. So it's a little bit complicated. There's three of them. So basically the model that I'm working on at the moment is the E70 with the halogen headlight. So as you saw on the car, the main beam is halogen and the dipped beam is halogen. The Bi-Xenon has dipped and main beam in the one projector, which is here. And then this projector actually hasn't got a light that shines out of this projector. It has a bulb in there which powers the halo rings, so the two rings around the projectors. So on the halogen version, let me just show you around the back of this. So the back of this Bi-Xenon light looks very similar to the back of the halogen light, but the arrangement of the bulbs is different. So imagine for a second that this is the halogen light that's on the car at the moment. There would be a cover here, where this one is, a cover there, and also a cover here. Now on this model, this isn't a removable cover, this is just a moulded plastic part, so this doesn't come off. But on the halogen version, there's a bulb behind here, and the bulb behind here on the halogen is to shine on the halo rings that go around the projectors. So the bulb for that is here, and it's a special bulb, proprietary bulb that would fit into this location here. So on the halogen light, this position is the dipped beam, and the bulb for that is an H7, and the high beam, or the main beam, is in this position, and the bulb for that is an H1. Okay, so moving on to the Bi-Xenon, which is this one. Again, the back looks very similar. The Xenon bulb, which is dipped and main beam, does both jobs, is in this cover, and that's a D1S bulb. That's a Xenon bulb. This one, as I said, doesn't come off. This isn't a cover. And the light here is the one for the angel eyes. So it's moved from here to here on the Bi-Xenons. And the light that's in here is an H8 bulb. So it's the 35 watt halogen H8 bulb. And that powers the halo rings. So we'll show you inside here. The covers. You can see there, this one here is the D1S bulb. Now that the D1S bulb requires a Xenon starter or an igniter pack, and that is underneath. So if you look underneath on a Xenon equipped headlight, you normally see a silver box like this, or maybe more than one, depending on what the bulbs are. But this box here is part of the Xenon light as well. But you can just replace the bulb, which is just in here. And then this one, as said, this is powering the rings around the light. So what I'm hoping to do is to fit this into the car, obviously keep the Xenon light, because this outperforms the halogen one that I've got. This H8 halogen bulb, which powers the rings, as you'll see in a second, I'll power it up for you, but when they light up, it gives a yellow golden glow, which halogen bulbs do. What I want to do is replace this with an LED version of the H8, which will be a higher colour temperature, 6000 I think the ones I've got are, which will produce a white light rather than a yellow light this one does. Now the way that the main beam and dip beam works on the Bi-Xenon, because it's just one, it's not a filament in that bulb, but you can think of it as a filament. You put power onto it, it's just two connections, and the bulb lights up or doesn't. The way that it distinguishes between high beam and dipped beam is that there's a shutter that comes down over the front of the bulb. So this bulb shines into a projector, and there's a shutter between the two. And when the dipped beam is on, the shutter is down, so it basically halves the light that comes out. So instead of the beam pattern being up and down, you know, shining all directions, this shutter comes down, which then limits the light to just on the floor. Basically, it can only shine so high, and then it cuts off. So if you aim these lights at a wall, you'll see that there's a definite line on the light. So everything below that line is lit up, everything above the line there's no light, and that's so it doesn't dazzle the oncoming road users. When you put the high beam on, it moves that shutter out the way and allows the full beam or the main beam pattern to come out of the light. And what I need to do is create a cable in order to accommodate that wiring, because the wiring is very similar, but it is slightly different. So we'll see that. I'll draw out some diagrams of what that wiring needs to be. But let me show you this this bulb here, because there's something else that's interesting about these halo rings. So I'm going to connect it up. I've got my power supply here. This is, I actually made this in one of the other videos, so I'll link that on the screen for you now. This is actually made from an Xbox 360 power supply, which you can see there, and it delivers high current. It delivers 16 amps at 12 volts, so it's ideal for testing high current car equipment such as these bulbs, because these will draw, you know, many amps. Some of these bulbs, especially the halogen ones. So you can see the light on the back there. Let's just turn this round. It looks very bright on camera there, but the center of that bulb, there's no actual light shining out of there, not a direct bulb anyway. The end of the bulb is painted so that it doesn't shine actually out of the projector. H8 bulbs are designed to shine sideways. So I'll show you, this is the LED version of the H8 that I want to fit into this, and you'll see that the LED chips are on opposite sides. So once it's fitted in, it doesn't shine out of this side or that side or the end. It's just these two sides here. And with the halogen bulb that's in here, you do get light actually coming out all the way around. But it's actually designed, the design of that bulb is just to shine from both sides like that. Now, the makeup of these rings is it's one bulb that feeds these light pipes around these two projectors, and the bulb, with it being here, is closer to this light pipe, and that's why this ring is very much brighter than this ring here. And it's the same on every E70 X5 that has the Bi-Xenons or the halogens. You'll see that this ring is always dimmer. You know, from factory, that's the way it was, and there's nothing you can do about that. It's just the way it's designed. The newer LCI ones that I was talking about, those LED modules, it has an LED module for each ring. So they've put one here and they've put one there, and they're very bright. And you know, each ring has their own LED module. But you can see there that the yellow glow to that, or the golden glow of the halogen light. So what I'll do is we'll just quickly swap that over for the LED. Well, let's just so have a look what current that was drawing. So that's just under 3 amps at 12 volts for that H8 bulb. That's 35 watts. So that's the halogen one, and the LED. It's a very similar size. You'll see that if you're buying one of these LED bulbs, a lot of them have a much larger base on the bottom. I got this one because it was the same size, but a lot of them have a heatsink built in there. Some of them have a fan as well, depending on what power these LEDs are, just to dissipate that heat. As the LED chips obviously last longer if they're kept cooler. So let's plug that in. I'll just switch it on before we put it in. It's going to be very bright. We swamp the camera out. There we are. But you can see, so if I go to the side like that, you can see there's no light, and at the end again no light, but the sides, that's where the light comes out. So let's fit that. Okay. You can see we've still got the brighter one here and the dimmer one there, but it's a whiter light rather than a golden light, which I prefer. But it's a personal choice. Most new cars have this white look now about the DRLs, the daytime running lights, but I've noticed that some brand new cars coming out do have an option for yellow ones as well, or golden ones, as that's what people prefer. So next, what I want to do is create that wiring loom. I think if I create a little harness with a plug and a socket, maybe 30 centimeters long, something like that, I'll put a plug and a socket on each end. It would just aid the integration of these into the car, rather than me having to hack into the loom and get it into tight spaces and stuff to put whatever changes we need in there. I'll make all the changes on this harness, and then we can just go to the car, plug in the harness, and the job's done. The current on that LED H8, that's just over 0.5 amp. Now, with these being different powers, there's a good chance that we're going to get some errors on the dashboard, some light errors, because it won't be expecting that particular current for that particular bulb. Now, we could go down the route of changing the FRM. The FRM is another name for the footwell module or the lighting module. This is in the footwell, as the module name suggests, and it basically takes a lot of inputs from the car. It powers the windows and the doors and does a lot of stuff. One of the things it does is control the lights, and the people that I've seen that have changed to LCI from a Bi-Xenon or halogen, they replace that footwell module as well. They also replace the light switch in the car, because that's slightly different, and they get the car coded as well. So they've got a code programmer and change the coding in the car to tell it what sort of light it's got. Now, what I'm intending to do is just put this light in as it is. I'll alter the wiring, put it in, and we'll see what happens. I'm pretty sure that the footwell module can control the halogen or the Bi-Xenon without a problem, but we may get some errors on the dash, so I may need to change the coding on that if I want to. You know, I might just live with the error light on the dashboard. The halogens at the moment are absolutely terrible. I can't see anything out of them at night, so I'll be glad of this regardless of whether I have an error on the dashboard or not. I've drawn out the schematic for the two headlight units, the halogen and the Bi-Xenon. The picture here is the connector. So this is looking at the back of the headlight unit. It's the same layout for both headlight units, and it's a 12-pin connector. There's 3 pins here, 2, 3 and 4. They're larger than all the other pins, so there's the smaller ones and then there's these 3 larger ones, but the same on both headlights. I've not included the indicator circuit on any of these because that's going to be unchanged. That isn't going to be changed with our wiring at all. It's just a straight 12-volt bulb connected to the ground. But the ones we're interested in are the beam and the dip beam and the DRL. I put DRL. This is the halo rings, the angel eyes around the projectors. That's what the DRL is. So on the halogen unit, it's really easy. We've got 3 halogen bulbs. We've got the one for the DRL, one for the dip, one for the main beam, all 3 separate ones. They're all grounded together on pin 4. And then we just have 3 control wires, all 12 volts to power those individual lights. So dead simple. On the Bi-Xenon, what we've got is that they've actually split the ground on the Bi-Xenon. So the Xenon bulb has its own ground, pin 2, which is one of the larger ones. That wasn't used on the halogen lights. So we've got pin 2, which is ground. I've put it straight to the bulb there, but it does go through that Xenon pack, the Xenon module that's underneath that silver module that you saw. But I've just drawn that as a bulb here. So ground and 12 volts on pin 3. So pin 3 on the halogen was the dipped beam, and pin 3 on the Bi-Xenon powers this bulb up whether it's beam or dip. From when you put the main beam on from within the car, on the old lights, that would have been on pin 5. On the new one, pin 5 activates the shutter. So what the shutter does, as I said before, is that depicts whether it's beam or dipped beam. So that bulb is on for beam, and the shutter is activated to move it out of the way. On the dipped beam, which is your normal headlights, then the shutter isn't activated and it drops down to cover part of the beam pattern on that bulb. So as far as I can tell, for dipped beam, this is going to work straight out the box. What I need to do is connect the two grounds together. So pin 4 is the ground for the DRL on both lights, but pin 2 is the ground for the dipped beam and the main beam on the Bi-Xenon. So what I need to do is join together the two grounds, and then when we put the lights on, put the dipped beam on, that will be pin 3, and it will light the xenon up, and the shutter won't be active, and that's correct because the shutter's dropped down. So dipped beam will work straight away. The main beam we're going to need to do a little bit too, because when we put the main beam on, in the old light it was pin 5, so I'm going to put 12 volts on pin 5, and it's going to operate the shutter, but it will only operate the shutter. It won't operate this bulb here because there won't be any power on pin 3. Pin 3 is only powered when the dipped beam is on. So if the main lights were on, dipped beam, and we pulled the control stick back for the to flash someone, then the shutter would move and it would flash someone because this light was already on. But if it's during the daytime and this light isn't on and we flash someone, all that'll happen is the shutter will click and move out of the way, but there won't be any light behind it, so it's not going to do anything. There'll be 12 volts here for the shutter, but what we also need to do is send that 12 volts to the bulb as well, to the xenon bulb. Now the best way of doing that, I think, is via a couple of diodes. So what we should do, I think, is put a diode here, across to that line, and I also think we should put another diode here in that line. So obviously it won't be in the unit itself, we're going to do it outside, but this is what it's going to look like. And the reason for having this diode and this diode together like this, rather than just joining up these cables, is we don't want to send 12 volts back down this line when we put the beam on. So if we put the main beam on here, 12 volts, if we just connected these together, it would also send 12 volts back into the control system, which I don't want to do because that will probably throw up some errors, or it might disable the lights or something. It might be something intelligent in the car which is detecting a fault there. But if I put two diodes here, that means when we power this line with the beam, and this one isn't powered, so we haven't got the lights on, but we want the beam on, 12 volts will be here, it'll activate the shutter, 12 volts will come across this diode to the light and light that up as well. But because this diode's here, we won't be able to send power back. It will stop here at this diode. And the same the other way. So if we didn't have the beam on and we just had the main dip lights on, there'll be power on pin 3, it'll come up here, it'll power the bulb up, and that's fine. But because of this diode here, we can't then send power back down this beam signal wire back into the electronics. So I'm going to need to put a couple of diodes in there. These xenon bulbs, I think they run at a couple of amps, 2 or 3 amps, so I'm probably going to get a 5 amp diode, maybe a 10 amp diode just to be safe, and we'll put 2 of those into our harness that we make. So I just thought I'd quickly show you this shutter activating. There's probably not much to see at the back, but on the left hand side there you might just be able to see the mechanism move. So if I put the main light on, so this would be essentially your dipped beam, so the xenon bulb is lit up, and then when I put power onto that shutter line, or the main beam line, the shutter will move upwards out of the way and and give you that larger beam pattern. So if I do that now, so if you just look just at the left hand side there, you might just be able to see that moving. That's just the edge of the shutter, but you can hear that clunk as it moves in and out. I'll just show you what that looks like on a wall. So this is the beam pattern with the shutter down. So this is the dipped beam pattern. You can see that definite line there on the wall. So the light is shining underneath that line, but above there's no light. So this stops it shining directly into the path of the oncoming cars. So if I activate the beam now, which will remove the shutter, lift it up out the way, you can see that that beam pattern now goes further up. And that's how the Bi-Xenon lights work. So based on this circuit, I have drawn out what I want to do with this new cable. I'll keep that in shot so you can see it. This is the wiring that's going to be on the adapter harness that I'd like to make. So we've got this side towards the car, so incoming cables from the car coming this way, and the headlight is on the right hand side as this diagram is set out. So the two diodes in place, similar to what we had here, and then we've got these two grounds connected, so 2 and 4, that links the two ground wires up as we've seen there. And most of the other cables are straight through. So pin 1 is the DRLs, or the side lights, that goes straight through, same pin for pin. Pin 5, that is the beam, so that's the same pin for pin. And the indicator, that's pin 12, again that goes pin for pin. Now these 4 other cables here, 8, 9, 10, 11, these are for the headlight level control. So within the car you've got the adjustment on the dashboard where you can manually alter the level of the headlights. Now I do believe that's different Xenon cars to the halogen cars, and I think the difference is that it has an auto level. I'm not sure if the halogens have an auto level or not, but I'm hoping that the 4 connections are just going to be pin for pin. So whatever I've got in the car now will control the motor in the new headlights in the same way. Now I couldn't find any diagrams for the E70 for the level control. I did find one for the E90. I'll put it up on the screen now. And as you can see, level control connections in the E90 are the same for the halogen and the Xenon. So I'm taking a gamble that the E70 is the same. The E70 and the E90 came out the same years, so it would make sense that the connections and the technology is the same in both of those. So that's what I'm going to do. This is the cable I'd like to make. Now I've got all the parts to do this. Got the diodes. These are some 10 amp silicon diodes, and I've also got the connector plugs. So I obviously need a plug and a socket so I can disconnect the car from the headlight and then insert this harness that I'm making and plug it back together. These plugs and sockets came from AliExpress. I've not tried them on the car. Haven't tested them to see whether they're exactly right, but they look right. So you can see there you've got the 12 pins. There's 5 along the top and the 3 larger ones in the middle, and then the row underneath there. So that's as per this diagram here. So that's the plug. You get 2, so 2 plugs and 2 sockets, and then this side is the socket. So this will hopefully just plug in there. Oh, the way up. That's it, that way. So yeah, disconnect what's in the car, plug this in, and we should be good to go. Now the way these plugs work is there's crimp connectors which you need to insert. So hopefully we've got larger ones and smaller ones. Yeah, so there's the larger connector and the smaller connector. So they just need crimping into the cable, and then they push into the back and will latch into place. So that should be fairly straightforward. And then I need to solder in the diodes into the wiring as well. Put some heat shrink around there, and that should be it. Got some cable here. This is 18 AWG, I think, cable, which is that's 1.25 millimeters. I'm not sure. I think it's 18. So this is good for, I think this is good for about 16 amps. So that is more than enough. Got a few colours there. I've obviously got two of these to make, one for each side, left and right, but the wiring will be exactly the same for both. So I will get on with that now. I bought this crimper to do these terminations with. I've not used it before. I think the cable, there's two parts to crimp down. There's the cable itself, and then there's a smaller one for the strain relief on the end. That seems to have worked. It's tight anyway. I'll do that with the others. So that's the smaller connectors on. Need to now put two blacks into the one connector so I can connect those together. That's okay. And then all I'll do is loop this back out and into the next connector. So that's pin 4, the one I've done here. And I'll loop this back out and I can come back into pin 2 for the other ground. And then the last large pin is pin 3. So that's the dipped beam. So there's our connectors done for the plug side. Now there are some grommets supplied here which I assume are for the back of the connectors, but I'm not sure there's enough for both sides, so perhaps these are just for the socket side. Yeah, I think they are. The socket side have these round holes which I assume these grommets will fit into. So I'll need to put the wires through these and they can be pushed back in at the end. I don't know why the plug hasn't got them. But yeah, it looks as though they're just for the socket side. So let's connect our wires up. Pin 1. Need a small screwdriver just to push that through. Pin 2. This one to pin 4. Okay, pin 3. This is the dip beam. Pin 5. Yeah, the smaller pins just need to be pushed through a little bit. They're a bit tight. I think it might be because of the cable. Perhaps this cable's a little bit too thick for those connectors. That's the top row done. That looks okay. So those two pins, 6 and 7, they're not used on the new headlights, or the old one for that matter. So I'm just going to leave those pins out. But yeah, that looks okay. So what I need to do now is put the diodes in, and then we can make up the other end. So what I might do is just duplicate this first. So I'll go away and just make a duplicate of this, and then at the same position, and then we can put those diodes in. So that's the other one done. I've just realised that I've done this the other way around. So this plug is actually this side. So this is a plug, the car is a socket. So this one is actually on the left hand side. So where I bridge this together here, this isn't going to do anything because pin 2 on this side doesn't connect to anything. So that's not a problem having it there. It just means when I come to do the other side, I'll have to remember to loop 2 and 4 together here as well. But apart from that, it'll be the same. So next thing to do is to do the socket side. I think we'll do the socket side first, and then actually no, I'm going to do the diode first because I may need to slide some heat shrink over, which I won't be able to do if I put that connector on. So yeah, I'll do the diodes next. Pin 3 needs to be cut. Put a diode in it. This is the way the connector goes. Pin 3 on this loom is the yellow cable. I didn't get green, so that's why we're using yellow. So this is the orientation it needs to go. I need to solder it in place there. I'll just cut this down a little bit. Okay, so the next diode needs to join onto this one. See, they're both connected there. So we might as well do that here. I might just put it that way around. So we're going from pin 5, which is this red one, and I'll probably go from this side onto there like that, just so when we heat shrink it, we can it'll be neater. They're not going to be next to each other, these diodes, to make the loom a little bit thinner. So the yellow wire will need to continue from the junction onto the other connector, and the red wire, that's basically straight through, but it needs to be connected to this end of the diode. So I'm just going to bare the wire a little bit in the center, and I can solder it to that diode there. One side is done, so that's how it looks. So we've got pin 3, which is yellow, coming into that diode, and it joins to the output of the second diode. Then the yellow wire carries on to pin 3 on the other side. The red wire is pretty much continuous through, but it connects to the input of this diode. So that is the way that I want it to be. Having the diodes like that, it just makes it a little bit thinner in the middle, So I can heat shrink that in the center, and that'll be okay. So I'll go ahead and finish these. I need to put the connector on the other end, and I'll do the same with the other one, and then we will come back. The two completed looms. I've moved the earth loop onto the right side, taking it off on the plug side. So plug and socket, put the heat shrink on, and those little rubber grommets, you see there, they fitted into the end of the case. You put them on the cables first, crimp it, put the crimp in, and then the grommets just push in to make that a little bit more waterproof, I think, although they're not supplied for the plug end, so they're only for the socket end, but I've put them in. So let's grab the headlights and we'll give this a test. So we'll plug this socket into the light. And then we can test the connections on here. So if we just bring this diagram back, this is pretty much pin for pin. So pin 1 is still going to be pin 1, which is the side lights. The dipped beam is now going to go through this diode, but will still be on pin 3. And it's the beam, it's the main beam that is going to be different here. So the main beam will power the shutter, which is on pin 5, and it's also going to power the xenon bulb, which is on pin 3. So putting power here should light the xenon, putting power here should light the xenon, but when you've got power here, it'll light the xenon and will release the shutter. It'll lift that shutter up over the light to give the main beam. So that one pin should do two things. So we've got our ground, so that is pin 4, which is this one. And let's try pin 3 first, so let's try the xenon on pin 3, which is the center. Okay, and we'll turn this on. That is lighting the xenon. Let me move this light around so you can see. So again, this is on pin 3. We've got the ground on pin 4 and the positive 12 volts on pin 3. If I turn that on, you can see the xenon bulb lighting up. But you can't hear you'll be able to see the beam pattern here, but you can't hear that clunk. The shutter makes that loud clunk noise. So that isn't taking place here. That is just the dipped beam, and this is the shutter down over the bulb. So this is correct for the dip beam. So if I move this to pin 5 now, we should hopefully see the xenon light and also hear that clunk of the shutter. Yeah, you can hear that. So let's just test the others while we're here. Pin 1 is the DRLs, or the rings around the lights. Yeah, they are both lighting up. This one is brighter, of course. And then pin 12 is the indicators. So that's the one down here. So that is it. That loom that we've created here is going to do the job on my car anyway. So that's from a halogen bulb car to a xenon headlight. This is going to do the job. The only question mark is these control lines, but I'm hoping that the level control is going to be the same on both. So I've just wired those pin for pin. An alternative to using diodes in this circuit would be to use a single relay. So I've redrawn out here another alternative that you could use if you wanted to use a relay. I've used the diodes in mine and it seems to be working fine, but this would be a good option also. So I've drawn in the lines that are relevant, the ground, the dipped beam and the main beam, so it's the same as what we had before. And this time we've got the relay in the center. This is a single pole double throw relay, which means there's a single switch in there, but it's a changeover switch. So this is the normally closed contact. And then when we have power onto the energizing coil, this switch moves over to this contact at the bottom. So the way this is going to work, we've got a ground line which goes from pin 4 to pin 4, and we've just tapped off that for one side of the relay. The other side of the relay is powered from the main beam line. So let's go through all the options here. The first one would be dipped lights on only, and that would be power on this one, but no power on the main beam. So power comes along here. It's already switched. Now the relay isn't energized here because that's only powered off the main beam line, so the relay isn't energized, but this is a normally closed contact. So this dipped beam line here will come straight through this contact, straight through to pin 3, which is the HID, and that's our lights on. If we have the main beam on and not the dipped, then this red line is powered. It energizes the coil, which will move this switch down to this contact. So this will break. This is essentially what the diode is doing. It's breaking that connection between the main beam and the dipped. So once this switch moves down, this dipped beam is completely separate then. That's out of circuit now. So the main beam signal will come along through this switch, which will now be closed, and power the HID. And it will also power pin 5, which is the shutter. So the HID and the shutter will come on together and give us that main beam. If both of them are on together, so if we have the dipped lights on and we wanted to pull back the stick to flash someone, what would happen is the main beams would be on, the dipped beam would be on anyway. We would pull the stick back to flash. It would actually disconnect the dipped beam circuit whilst the switch moved to this position, and then we would be using the main beam. So again, HID and shutter. And when we came off that flash, this one would switch off. Coil would be de-energized. Switch would move back to the dipped beam, and then the HID would be on again. So both of these circuits would work in the same way. Just depends what you want to do. The diodes are a bit neater because you can have them in line on the harness a little bit neater, but there is a slight volt drop with a diode. Silicon diodes, if you're using silicon diodes, I think the volt drop's about 1.2 volts. And because there's a volt drop, there will be some heat from these diodes. So just be aware of that. The diodes, if you're getting 10 amp diodes, then they can handle 10 amps. It's not a problem, but they will get warm. The relay, of course, there's no volt drop. and no heat generated. But it's a bulkier device. You've got a physical relay to put in the line there. But yeah, just two options, either or. So that's where I'm going to end this video now. These two harness methods that I've shown you, these are going to work for the halogen headlights to the xenon headlights. I think the LCI LED version of the lights, it's not going to be quite as simple, where the wiring might be similar. The module that's in the car won't control those LED lights quite in the same way that it would with the halogens or the xenons. So I think you'll probably get a few more issues there. Maybe the LEDs will flicker or something like that. So I can't say whether that would work. But this method will work for halogen to xenon, if that's what you are trying to do. So I hope this has helped you. And if you've got any questions, leave them below and I will try and answer them for you. Thanks for watching, and I will see you on the next one.